Hey guys, so today we're going to do 3.2. We're going to focus on graphing, okay? So this might be a short, like there's so many examples, but it's the idea of graphing, that's it. So let's take these step by step and remember what we need to have. So when graphing, the first thing we need to consider is the domain, okay? As we can see in our domain, if I were to simplify this, I have x minus 2 times x plus 2. That's the difference of squares. Okay, so that means that x cannot be negative 2 and 2. So when I write that domain, I have negative infinity to negative 2, negative 2 to 2, and 2 to infinity. Okay, now what else do we need? Well, we need our intercepts, right? So we have an x-intercept, and what you need to do is set your numerator equal to 0. So we have 3x equals 0, and when we solve, we have x equals 0. Now, the intercept is a coordinate pair, so make sure that you write down the coordinate pair. Remember, when this is solving for x, so the x-intercept is also when y equals 0. Okay, now y-intercept is from where x equals 0. Well, of course, if we plug in 0 here, we get 0 over negative 4, which is 0. And that makes sense, right? Because if we have an x-intercept at the origin, the y-intercept is the origin. Before I move on, I'm going to remind you that we still need to figure out if the x-intercept, this doesn't go for the y, if the x-intercepts are even or odd. Why do we need to know that? Remember, if they're even x-intercepts, they touch, and if they're odd x-intercepts, they cross. We did that last year in secondary 3. So if we look at the intercept, this is to the first, right? So that means it is an odd intercept, which means it crosses. Okay. Now, after intercepts, let's look at our vertical asymptotes. We look at our vertical asymptotes first because if we find out there's a hole and that hole was already a vertical asymptote, the vertical asymptote trumps the hole. Because of course, if you never get to that line or the x equals, you'll never get to that hole, if that makes sense right now. So we have a vertical asymptote at 2. So x equals 2 and x equals negative 2. If you're wondering how I got that, I take each piece of the denominator and set it equal to 0 and solve. Now, the x-intercept, of course, was a coordinate pair, so we have x comma y, but the vertical asymptote is actually a line, right? So our answer is x equals. Now, if we look at holes, there was nothing that we crossed out. Now we're going to take what we learned the other day about horizontal asymptotes and see if there are any there. Okay. Now, if we go back to the original problem, I look at my leading term, which is a 3x over x squared. And in this case, our P is less than Q. So that means we have a horizontal asymptote at y equals 0. Right now, this is where I'm going to start lining things up. All right, let's put in our y and x intercept. We put in our vertical asymptote at negative 2 and 2. And with horizontal asymptotes, and let me get a marker for this so you guys can see it. The horizontal asymptote, I'm not going to put in the middle. I put it at the end because that's where the end behavior is going 2. Okay? Now, we have everything. But the problem is, how do we draw it? Where does it end up? Okay? So this is where you might plug in points. Okay, here's my other issue, and I'm sorry I didn't say this. Vertical asymptotes are also even or odd. These are odd because it's to the first. Now, what does that have to do with anything? What that has to do with is that when one goes down, the other one goes up if it's odd. It's even, they both go in the same direction. I know that's something new, and we'll get used to that as I go along, okay? So in this case, we might plug in a point. So let's see, is our graph above or below? Okay, well, if it's above or below, why don't we look at what if x is -3? So what we're gonna do is make a small table, and in our calculator, plug in -3 to our equation. When you do that, you get -1.8. So I know that it's down here. Okay? Then what I also know is, because what do graphs do with vertical asymptotes and horizontal asymptotes? They get really close. Okay. Now, why did I mention even and odd asymptotes? Well, that's because odd ones, remember, because it's to the first, oh, it's that one, to the first means they're in opposite directions. So if this side is going down, this side must be going up. Now, this is why actually we only needed 1 point, okay? I know this side's going up, and I also know at this X-intercept, it crosses. So I'm gonna bring this down and cross it. Now, where does it go? Does it come back up to this vertical asymptote, or does it keep going down to that vertical asymptote? Well, it has to go down. Why? Because if it were to come back up, we would have another X-intercept, but we don't. We only have one. So the only other position this could do is go down. Now, if we look at the vertical asymptote at 2, it's also odd. Wow, did I not put a negative in there? Which is right here, and that is to the first. So that's why it's odd. And odd, again, means if one goes down, on the other side, it goes up. There are no X-intercepts on this side, so that means this continues and gets really close to that horizontal asymptote. And this is a nice little sketch. If you wanted to do more points to figure out where it was in here and out here, go for it. But it'd be nice to use that trick of the odd and even asymptotes. Okay, let's go on to the next one. We're going to fill out all of our information first. Okay. One thing I see is I'm going to see if I can simplify this. Well, I can take an x out, and then it is factorable. When you factor it out, you get x minus 3 times x minus 3. So what I'm going to do is show that as squared, because that helps me with my even and odd. If you have to, try it on the side. Make sure you have your factoring down. Next, let's talk about domain. Well, domain cannot be 0, and it cannot have 3 in there, because then we would have 0 in the denominator. So I go from -infinity to 0, 0 to 3, and 3 to infinity. Let's do our X-intercepts next. Okay, set our numerator equal to 0. When I do that, I get that x equals 2. Remember, at an x-intercept, y is 0. This is to the first, so this is an odd, which means it crosses. Y-intercept is when x equals 0. Well, if you look at this, x equals 0, well, we just said that the denominator cannot be 0, so that means there is none. So we can't have 0 in that denominator. Okay, next, vertical asymptotes. So we have a vertical asymptote at x equals 0. And that one's to the first, so it's odd. And our second vertical asymptote, well, what can that be? That can't be 3. Now, if we look here, that exponent is 2, so it's even. Let's look at our horizontal asymptote. Okay, I'm going to go back to the original for this. So I have my two leading terms. So I have negative x over x cubed. Well, again, p is less than q. So y equals 0. Okay, let's label all. But as you are doing this, or as I'm doing this, can you please write down your intercepts on your graphs? Lovely, right? There we go. Okay, so we have an x-intercept at 2. Oh, why did I put that down? Sorry, guys. X-intercept at 2. Ignore this. Ignore it. I wish I had whiteout. This is why you don't use pens. Okay, we have a vertical asymptote at 0. There we go. Maybe it will cross out there. And a vertical asymptote at 3. We have our horizontal asymptote at 0 again. Okay. Now, let's talk about points, right? Because again, we don't know which one it's going in. So let's plug in. In this case, because our vertical asymptote is at 0, we could plug in -1. When we plug in -1 for our x's on your calculator, you get -0.875. So that means we're somewhere down here. So what does that tell us? Well, there's no other x-intercept here, so it must go close to the horizontal and must go close to the vertical. Okay, again, because there's no x-intercept here, we know it has to stay under. Now, because 0 is an odd, okay, 0 is an odd, it has to start over here, okay? And we know at this x-intercept, it has to cross. I'm going to cross. Now, I can't go back up, just like from the one I just did, because there's no x-intercept, so this must come all the way down. Now, this vertical asymptote is an even. Even means they're going in the same direction. So if this side is going down, this side also must be going down. That's the difference. Odd has them going in different directions, even has them going in the same. There's no x-intercept here, so it must get very close to that horizontal asymptote. Yay! See, we don't need a graphing calculator, guys. We've got this. Do some more. Okay, let's do our factoring first. Okay, remember A times C, do your grouping, everything like that. When we do that, we get 2x minus 5 times x plus 1. Please do that on the side right now. You can pause the video, try it by yourself, make sure that's what you get, so that way we can see if we need to practice our factoring. And then on the bottom here, we also factored that. Pause, check out your factoring. You should get x minus 3 times x plus 2. Okay, so domain, remember domain, we look at our denominator. So we know that we're going from negative infinity to negative 2, negative 2 to 3, and 3 to infinity. If that was too fast and you're wondering where I'm getting those numbers, well, I asked myself, what can't x be? X can't be 3 and x can't be negative 2. And that's where I got that. Okay, X-intercepts. Now, remember, it's setting the numerator equal to 0. So I'm going to set 2x minus 5 equal to 0 and x plus 1 equal to 0. When we do that out, we get 5 halves. It's a point, remember? And negative 1. Let's check our Y-intercept. Y-intercept is when our x is equal to 0. The easiest thing to do is go back to your unsimplified function and plug in 0. Well, that would be negative 5 over negative 6, which is 5/6. All right, next step is our vertical asymptotes. Well, we have it at x equals 3 and x equals negative 2. Now, I noticed, guys, that I went so fast that I forgot to identify even and odd. And remember, that helps us. So if you forget to, as you're graphing, go back and do that. All of these are to the first, which means that makes each of these x-intercepts an odd, which is a cross, and these vertical asymptotes an odd, so they go in opposite directions. Okay. Horizontal asymptote. Oh, we're changing it up a little bit, aren't we? If you see, the numerator is 2x squared and the bottom is x squared. So what happens again when p equals q? Well, we take the coefficient. So y equals 2. We have a horizontal asymptote at y equals 2. So let me start graphing and see what that looks like. Okay, so 1, 2, 3. We have an x-intercept at negative 1. We have a vertical asymptote at 3. We have a vertical asymptote at negative 2. Okay, now this is great. Now we cross. Now we don't know. Could we cross this way or could we cross this way? We don't know. Nothing tells us anything. Let's label our horizontal and then plug in our point. Horizontal is at 2. Now remember, I am not going to go straight across with this. What I am going to do, though, is just put my asymptotes at the end. Okay? All right, now we need to plug in a point to see where our values are going. So I'm going to always start on my left. It's just habit, guys. So I'm going to plug in negative 3. Sounds good? When I plug in -3 into the calculator, I get 3.66 repeating. Okay, that means at -3, I am, let's see, that was 2, and this is 3, so I'm up here. All right, well, where does that bring us? Well, we can't cross here, so I must hug those asymptotes. We good? Okay. Now, another thing is, I forgot to graph my y-intercept. My y-intercept is 5, 6, which is less than 1. Okay? All right, so let's think about this. This vertical asymptote right here is odd, so it must be coming down here. And I know I cross the x-axis there. Now it has to go to that y. Okay, so it has to somehow, whether it goes up and then down or anything like that, must go to that y. And then that y has to go to the x. So it has to somehow come down like here. Right? Now it crosses. So what happens? Well, if it crosses, it must hug the other asymptote. And because this asymptote here is odd, this one must go up because odd is opposite. And then it won't come back down, but I know that it will hug that asymptote at 2. How is that, guys? We're almost there. Ah. Okay. Ooh, we're getting some even ones here, huh? Okay. Domain. Look at the denominator right now. What can't it be? It can't be -1 and it can't be +2. So -infinity to -1, -1 to 2, and 2 to infinity. X-intercept, remember, is when the numerator, x plus 2 equals 0, and x minus 3 equals 0. Now, could I put x plus 2 squared equals 0? Yes, but how do you get rid of the square? Excuse me. I take the square root. What's the square root of 0? 0. Okay, so when I solve that out, I get an x-intercept at -2, 0, and at 3, 0. This time, let me do cross and touch right now. -2 up here is an even, so it must touch. Where 3 is an odd, so it must cross. Y-intercept is when x is 0. Okay, so we can plug that in. So 0 there, we would have 2 squared, which is 4. 0 there would be -3. So 4 times -3 is -12. Again, you guys have the calculator right now, so you can do that. 1 squared is 1. -2. -2 times 1 is -2. So we have a y-intercept, which is 0, 6. Then we have vertical asymptotes, right? Look at our denominator. That's x equals -1 and x equals 2. At -1, it's an even because the exponent is 2. And at 2, the exponent is 1, so it's an odd. Okay. Horizontal asymptote. Okay, this is a tricky one that most people mess up. Excuse me. What I want to do is I'm going to look at my term and the exponent. Term and then exponent. So this is x squared times x to the first, which gives me x cubed. And then on the bottom, I'm going to do the same. X squared times x to the first is x cubed. I'm only doing that. I'm not foiling out all the way because all I need for horizontal asymptotes is to look at that leading term. So that's the only reason why I did the x's, which right now that means P and Q equal. So I use the leading coefficient, which is y equals 1. All right, let's see. So we have x-intercept at -2. Now be careful because that touches. So let's remember that when we graph. 1, 2, 3. That one crosses. We have a y-intercept at 6. 1, 2, 3, 4, 5, 6. We have a vertical asymptote at -1. We have a vertical asymptote at 2. And our horizontal asymptote is at 1. This one's going to be a tricky one, guys. So be careful. Oops, I should do it over here. There we go. Okay. All right, we got to figure out where we are at, right? Are we up or are we down? So let's do what we've usually been doing. So let's try at -3, okay? So if x is -3, what do we get? Well, of course, I did not plug it in, so I'm going to have to do it in right now. Let's see. -3 plus 2 squared times -3 minus 3. So that gives me -6 on top. On the bottom, I would get -3 plus 1 squared times -3 minus 2 equals that. So I get -6 divided by -20 equals 0.3. So at 3, I'm at 0.3. I'm up here. Okay, so what does that do for us? Well, let's see. If it's above, and here's my horizontal asymptote, that means that I'm going to be curving towards the asymptote. Okay? Now, of course, then I'm going to go to my x-intercept. We have an issue here, right? Because at -2, it's supposed to touch. So I'm not going to go down here. I'm going to bounce back up and stay close to that horizontal asymptote, or that vertical asymptote. This is also why the horizontal asymptote you do not do straight across, because as you can see, this went over it. Because it's at the end, it's coming to 1. Okay, now at -1, we are even. So what does even mean again? Even means that I'm going to be in the same direction. So I'm going up. Now I put that up there, guys, because since this is an intercept, I'm going to have to come across here. Now, what happens? What can I do? What's the judgment? Well, unlike the other ones on the other page, I'm not going to go down because look, there's no x-intercept right here. If I go down, there would have to be one, but there's not. So I must be going up. Now, if you are unsure of that, you can always plug in another value. And of course, I did not write that value down, did I? There we go. Sorry, guys. You can always plug in to make sure that's the way it goes. All right, so now we're back to this vertical asymptote. This one's going up, and this one's odd. So this one must be going down. So I must connect it with this x-intercept. This x-intercept crosses, so I'm going to cross over it. But what happens here? I have to go towards, as I keep going, I'm going to go towards my horizontal asymptote. Okay. Very good. If you need to test values, you can always test values. Okay. One last thing, and then we're done. We're going to go backwards. Now, when you go backwards, remember that when we make a function, we can't assume that A will be 1, okay? So one thing I want to point out are X-intercepts, which come from our numerator, and our vertical asymptote, okay? So first of all, I know I have a vertical asymptote at 2, and it is even. So what does that mean about our function? Well, that means f of x equals, I'm going to write a here because we don't know what a is. Remember, we were doing that in the last couple chapters. And then I have my numerator denominator. Vertical asymptotes come from the denominator. So if I want a vertical asymptote at 2, it's going to be x minus 2. Remember, it's opposite. And since it's an even, it must be an even exponent. So I'm just going to make it squared because we're going to write the lowest function it could be, okay? Now, just be careful because there's another vertical asymptote. There's a vertical asymptote at -1. And that goes in opposite direction, so it's odd. So that means in the denominator, I also have x plus 1, and that's going to be to the first. Okay, I'm going to change colors on you so you can see where I get this from. In the numerator, that is about our x-intercepts. So I have an x-intercept at 3. And as you can see, it crosses, so it's odd. And then I have one at -2. And it crosses, so it's odd. Okay, so how do I write that? Well, I would write x plus 2, and that is to the first because it's odd, and x minus 3 to the first because then it's odd. Now, the reason why we know our y-intercept is because that's what we use to figure out a. Our y-intercept says when x is 0, y is -2. So I am going to plug that in. So we have -2 equals a times 0 plus 2 times 0 minus 3 all over 0 minus 2 squared times 0 plus 1. Okay, now let's simplify that so we can see what happens. So we get -2 equals, and what happens is on top we get -6, on the bottom we get +4, and this is times a. We can simplify that more. So -2, or we can just solve from there. Get rid of the 4, we multiply, so that's -8 equals -6a. Divide by -6, we get, and simplify, we get 4/3 equals a. So, what is our final answer? Our final answer is that our f of x function equals 4. And now you could put 4/3 in front, or we could just put 4 with the numerator. So 4 times x plus 2 times x minus 3 all over 3 times x minus 2 squared x plus 1. Awesome. Just be careful and remember that even vertical asymptotes go the same way. Odds go opposite. All right, guys, good luck.